Hello everyone, welcome back to my YouTube channel. So today in this video, I'm going to talk about 8 different terms that software engineers recently started using and people may not be actually aware of what are the exact meanings to those terms. So they could be simple words which you may not be aware of, and I have picked a few of the words for you to basically understand with examples. The first term is RAG, Retrieval Augmented Generation. So let's see what Google tells about this word. Retrieval Augmented Generation is the process of optimizing the output of large language models so it references an authoritative knowledge base outside of training data resources before generating a response. Say you have a document store. Now it contains 3 documents. For example, say the first document says Docker is used for containerization applications. And the second document says Kubernetes is an open source application for automating deployment process. And the third document says Terraform helps manage infrastructure as a code. Okay. These are all the documents that are present in the document store. Now, say someone comes and asks, what is Kubernetes used for? If it has to rely only on the training data, it may not give you the correct and accurate results here. Rather, what happens is it goes the 2 documents. Since the question is about Kubernetes, it goes retrieves the document 2 and then as it mentions about Kubernetes directly. And after retrieving this document, it generates a response based on the content that is present in the document. RAG is basically referring to some data sources to bring data for you based on the question that you are actually asking. So this is what RAG is. How it basically works is it will convert your question into vector form, which is like a scale of values. Now, these scale values will go and compare themselves with the documents and will see the most similarity. For example, there are different similarity indexes like cosine similarity, Euclidean distance. You'll find the closest similar document and then pulls the document. Now, it takes this document and the question by the user and gives it to the generator for it to generate a response for the specific question. Now let's move on to the second word, embeddings. Let's see what Google says about embeddings. Embeddings are numerical representation of real world objects that machine learning models and artificial intelligence systems use to understand complex knowledge domain like humans do. Okay, let me put it simple now. When the question was about, like, say, there is a sentence called Kubernetes is great. So now this gets harder for the system to understand and process that question because it's hard to read the text. What it does is there are certain embedding models which will convert this question into a vectorized form of embeddings, which means basically numerical value of representations. Now it becomes much more easier for the system to perform any mathematical operations on top of it. For example, now they can apply a cosine similarity or Euclidean similarity or Manhattan distance or anything they wanted. Some of the famous models are OpenAI embeddings is one of the famous models which generates it based on the inputs that you give. And another model is Word2Vec. So this also helps in generating embeddings. There will be 5 steps to it. I'm not going deep. There are multiple layers to that. But for example, say an input comes in, say Kubernetes is great. Now the process of tokenization happens. Tokenization is nothing but identifying each and every token that is present in the whole sentence. Next, after tokenization, there is an embedding layer which generates these embeddings. And then next you will have the transformer layer, and then you will have the pooling. This pooling basically combines the vectors into a sentence, and then it moves to the next step and gives you the final output like a vector of numbers for the specific word that you have given. That is what it means by embeddings. The next word is vector databases. Vector databases are nothing. It is simply some database which will store these vector values. For example, say there was a sentence like Kubernetes is great. Now this embeddings model generates embeddings and this needs to be stored somewhere, right? So they are called as vector databases to store this vector kind of data. So if you could actually store them in the vector databases, there are multiple features that you have, which you can basically apply on top of this data. For example, you can do similarity search, you can do top K, and then you can do filtering based on specific metadata details. And there will be an option for us to index things in real time. And also, if this embeddings need not happen only on specific text, it can happen on images. That is what we call as multimodal search. So there are many vector databases, phase and code of the phase vector databases. And there is also a vector database which was built by Redis, which is called as Redis vector, and chroma DB is also very diversely used among the ML engineers. The next word that you have to know is tokens. So let's see what Google says about it. A token is a fundamental discrete unit of value that a model processes. What it means is a token can be a word or it can be a part of a word. For example, say there is a word called as don't, DONT, right? So DON, and you will have a apostrophe and then T. Now DON will become a separate token. You can consider it as a whole token as well, or else you can consider it as a separate token. And then the apostrophe will become a separate token and T will be a separate token. So a token is something, a very discrete small unit of maybe text. If it's a text, then you can split it into multiple components and you can call everything as an individual component. So here are a few examples that you will see on the screen for tokens. Now let's move on to the next word. The next more familiar term is that context window. So let's see what Google says about this. A context window is a fundamental concept in machine learning that refers to a fixed amount of information a model can consider at one time while processing a sequential data. It is nothing but you have to think of it as a sliding window. For example, say there is a sentence like I love Kubernetes and containers. Okay. Now your say the context window length is at most set to 4. Now only the last 4 words of this will be available for the machine learning model to process. Anything that is beyond that limit will basically be left out. That is what a context window means. So this context window changes for different models. Here on the screen, I am mentioning all the context window for all the familiar most popular models. GPT-3, 4, Claude, BERT and Llama models. You can see the context window length that they have mentioned, and with the pro versions of it, it keeps increasing, which will basically help the people who are utilizing these models to give more context to the model and get data out of it. Now let's move on to the next word is multimodal. Multi means many, and then modal means different types of. That is what they mean. Many different types of input is called as multimodal. A modality can be text, image, could be a audio or video or even code. It could be any type of input. So that is what they mean by multimodal. Some of the popular models are GPT-4 Vision, which will take both text and images input. Next Gemini 1.5. This takes text, image, and video, all three as input. The next is Claude 3 Opus. It takes text and image as input. Sora is basically a video generation model. Whisper takes audio as input. Flamingo or Cosmos, these are all image plus text kind of models. Can we combine the model? You can retrieve text and image from a PDF document and you can basically ask questions on top of it. So based on your question, it will be converted into a embedding, and then these embedding will be vector values where you can apply the similarity index and you can pick the most similar data and give it to the model to basically generate the details. So multimodal is nothing but multiple different types of input is what multimodal means. The next term that you may hear more often is quantization. So let's see what Google says about quantization. Quantization is a technique used to reduce the memory footprint and computational cost of a model by decreasing the precision of its numerical representation. Okay, let me clearly tell what it is. Say there is a model that is using a 32-bit floating point. Okay, now when I apply this quantization technique, it will basically reduce it to 16 and 8. It will just keep reducing one by one. That is what quantization means. There are different types of quantization: post training, quantization, aware training, dynamic quantization, and static quantization. There are different types of quantization. I don't want to get deeper into each one of this because it will be a little long. But the question you may get is, why do we need to quantize something? Okay, when you quantize something, the speeds of the inference may increase. Also, the size of the model will go down, and the cost of running that model can also get lower. Also, you should be aware that there will be a slight loss of accuracy as well because you are quantizing from the precision of the 32-bit and 16-bit or 8-bit which you are quantizing to. There will be a little bit of loss in the precision as well. So we have to do it in a right way. After understanding every aspects of the model, you should do this quantization. So the next word that you may hear is fine tuning. Let's see what Google says about fine tuning. Fine tuning in machine learning is the process of adapting a pre-trained model to perform a specific task or domain by training it on a new, often smaller dataset. Let me take an example to explain you this. For example, say there is a model called as layout LLM. So this specific model is trained on form kind of documents, which means there are different forms, right? It could invoice kind of a document, it could be different kind of form document. It is trained to pull the data out of that kind of documents. Now, say I work in a specific company and I have some set of forms and I wanted to give this as an input to the already pre-trained model, and this model will basically retrieve data from my forms as well. Now, what happens is there will be some accuracy differences as my layout of the forms will be little bit different compared to the other forms which was already pre-trained. Now, what I will do is I will take a sample set of data from my forms and then I will train this model, which means basically fine tune this model with the data that I have specific to my use case. Now, what happens is given that model gets trained on the specific set of new data, the prediction accuracy to retrieve results from my documents will be much better and it will be much more improved. This is where fine tuning comes into picture, and that is what fine tuning means. So if you really like this video and if you find this content really helpful for you to learn something today, please subscribe to my YouTube channel and comment down in the comment section what do you want to basically see next in this channel. So let's meet on the next video. Thank you for watching this video till the end.